Hello friends, thank you for joining me in today's presentation. We continue with our solutions to how to find the domain of any function. In today's presentation, we are looking at case 4. In my previous video, we have looked at case 1, case 2, and case 3. This is case 4, square root in the denominator only. When we have square root in the denominator of a function, how do we find the domain? How do we find the allowable possible values of x that will satisfy that given function, like what we have on the board? If you are coming across this channel for the first time, thank you for coming. The returning viewers, I really appreciate you. Thank you for joining me. Let's look at how we can find the domain of this function. Domain, what are the possible values of x that we can plug into this function and the function will exist. Very simple. Let's look at how we can solve this. Find the domain of g of x given as x squared plus 2x plus 3 divided by the square root of x plus 1. The square root is in the denominator, so we concentrate only on our denominator. So we pick what is under the square root here and set it to, it must strictly be greater than 0. Why? Because division by 0 is not allowed, does not exist, is undefined. So anything that will change what we have under the square root to be 0 is not allowed here. So whatever we have under the square root must be greater than 0. Let's solve for x here. X now will be greater than minus 1. X will be greater than minus 1 because this is plus 1. If plus 1 crosses this inequality sign, it will change to be negative 1. So what are we saying here? So we can state the domain. The domain now will be all real numbers greater than minus 1. All real number, but it must be greater than minus 1, because if we put minus 1 here plus 1, we'll get 0. So the domain, can state the domain as x such that x belongs to the set of real number, but x must be greater than minus 1. So this will be the domain. X such that x belongs to the set of real number, but x must be strictly greater than minus 1, meaning x must not be minus 1. But any number more than 1 can take a value of x, like 0, 1, 2 in that order. So in other words, or we can state it as minus 1 not included, but any positive infinity is in. We can use interval notation. This is another way of stating the domain of this function. We can say minus 1, this square bracket means not included. Not included. Meaning minus 1 is not included. No, sorry, minus 1 is included. No. It's supposed to be square bracket like this. It's supposed to be like this. It's supposed to be a normal bracket like this. Why? Because this bracket means not included. Not included. But if we put square bracket here, square bracket means it's included. But this bracket means like minus 1 not included to positive infinity not included. Okay, positive infinity is not included because we can't reach infinity. Minus 1 again not included, positive infinity not included. So this is interval notation. We can either use interval notation or we use this other method. Or we can say all real number except x greater than minus 1. That's another way we can state the domain of this function. Thank you for watching. Please do share this to your learned colleagues. And don't forget to subscribe to TJ's Maths and Further Maths Adventures. You can follow me on TikTok, Instagram, and Facebook. Thank you for support.